Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Sudoku en rouge, jaune, bleu, et noir by Michael Lefkowitz. I might have messed up the French pronunciation, so apologies for that, but I did it best I could. Sudoku en rouge, jaune, jaune? I don't know how to pronounce it. Bleu et noir. I don't know. My French is not very good, so pardon my French. Anyways, here are the rules. We need to place a digit from 0 to 9 in each non-black cell so that no digits repeat in a row or a column. Okay. Regions of the same color have the same sum. So white is a color. So, for example, these white cells must be equal to the same sum as these white cells, which must be equal to the same sum as these white cells. That's interesting. Huh. Regions, yeah. So along diagonal lines, digits increase in one direction. So, for example, you could have something like 3, 4, 6, 8, 9, and that would be valid because it's increasing in one direction. Or it could obviously be increasing in the other direction. So you could have something like 0, 1, 5, 7, 8, and that would be valid because it's increasing in one of the directions or the other. And finally, so I think this is a 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's 8. It's an 8 by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, it's an 8 by 10 puzzle. So that should give you some information. Along so also we finally have small squares, outlines, all sorry. Small square outlines all contain different digits. So these small square outlines all contain different digits. And those are the rules. Those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So the white is interesting because this white has 6. Oh, there's no repeats in row or column. Never mind. I was going to say something, but that doesn't make any sense. Okay. Yeah, I was thinking that there would be no repeats in regions, but that's not guaranteed. So it could be 0, 1, 2 plus 0, 1, 2 at minimum, which would be 6. We know there's a digits 0 through 9 in every column. In every row, we're missing 2 digits. Oh, wait. No. So black is not a region, I guess. So we don't place digits in these regions. That's interesting. Okay. 0 to 9 in each non-black cell, so that no digit repeats. Right. So we don't have digits here. That's interesting. Okay. Red equals red. So 3 digits, which is 24 at most. You could have 0, 1, 2, and 3 in each of these rows. So that would be 6 times 4. which is exactly what you have to have. So this has to be 7, 8, 9. And these have to be 0, 1, 2, 3. Because 0, 1, 2, 3 adds up to at minimum 6 for every row. Well, 6 times 4 is 24, which is the maximum this can be. So this is 7, 8, 9. This is 0, 1, 2, and 3. So it must be increasing or decreasing going this way. Well, if it's decreasing going this way, that doesn't work. Because then it would be 3, 2, 1, 0, and there's nothing less than 0. So this must be 0, 1, 2, 3. So this is 0, 1, 2, and 3. Obviously, none of these can be 3. None of these can be 2. And none of these can be 1. And none of these can be 0. So, remaining digits in each of these rows is 4 through 9. Obviously, this can't be 7, 8, or 9, so this is 4, 5, or 6. This can't be 7, 8, or 9, it's 4, 5, 6. This can't be 7, 8, or 9, it's 4, 5, 6. Okay, so this is 4, 5, 6 then. This is 15 at least, and you can have 0, 1, or 2 here because each of these... you can't have 0, 1, or... It can't be 2. It can't be 1. It has to be 0. Because 15 is the minimum. You cannot have 16 in any of these columns because that would require 7, 9, and 7, 9 here. You can't have 17 for the same reason. You'd have to have 8, 9, 8, 9. So this has to be 0. So this is 0. So all the whites add up to 15. So any two-digit number must be 6, 7, 8, 9. So you have 6, 7, 8, 9 here, 6, 7, 8, 9 here, 6, 7, 8, 9 here. So these are all 6, 7, 8, 9s as possibilities. Well, we have a 6, 7, 8, 9 quadruplet in column 7, which eliminates 6, 7, 8, 9 in the rest of the column. So these cannot be 0 through 3 either. So next 6, 6, 7, 8, 9. So this must be a 4, 5 pair here. This digit is larger than 3, but it cannot be 6, 7, 8, 9. So this is 4, 5 also here. Remaining digits in column 7 are 0, 1, 2, 3. So these add up to 15. This adds up to 15. This cannot have 0, 1, 2, or 3 here. So it's 3 digits, so it's 4, 5, and 6. Which eliminates 4, 5, and 6 in the rest of the column. So this can't be 6. These can't be 9, because they must add up to 15. So this has to be 7, 8, or 9 here. None of these can be 0 through 4. So it's 4 through 9 here. Okay. Both of these sets, so whatever is the 15 here, they cannot be the 15 here, so these must be the same digits. So these are the same set, and they cannot to add up to 15, and these must be a different set. Okay, so let's make this orange, and this is green. So this must be orange here. The set of adding up to 15 there. These cannot be adding up to 15, so these must be the green sets. We don't know about this. This adds up to 15. We don't really have that many restrictions here. These can't be 0 through 3. That's all we know. So this is 4 through 9 here. So we're guaranteed a 9 here. We're guaranteed 4 and 5 here. So if we have 4, 5, and 9 somewhere here in column 5. What is this at minimum? This is 9 plus 9 at minimum, so yellow is at least 18. This is 15. Obviously cannot be 4, 5, and 6, because that would eliminate all possibilities for that cell there. These are the green, these are the orange 15s. We don't know which ones this is. This could be green or orange. We are guaranteed this cannot be 9. So this has to... Oh, it doesn't have to be 6 and 9 here. These could be the same set. Yellow adds up to at most 18. Sorry, at minimum 18. This is guaranteed to be 2 and 3 at maximum. 18 minus 5 is 13, so this has to be at least 13, which means this is 4 through 9. But the problem with that is if this is 4, I guess it could be 6, 7. That could work. Can you ever have a 9 here? Is kind of a question, right? Well, we have a 4, 5, 6, 7, 8, 9 sextuplet in column 6. So that leaves 0 through 3 as the remaining digits. This can't be 0 because of 0 in the row. This must add up to 15 here. Okay. Can this be 4 or 5 here? If this is 4, this would have to be 5, but then that would be 4, and that would be not possible. So this cannot be 4 or 5 here. It must be increasing from this direction. 6, 7, 8, 9 is definitely going to be less than 4, 5, and 6. Sorry, it's going to be greater than 4, 5, or 6. So it must be decreasing going this way. And this can't be 0 through 3. These can't be 0 through 3, so this is 4 through 9 here. This has to be less than this, so it's 4, 5, which means this is 5 or 6, which means this is 6, 7, or 8, which means this is 7, 8, or 9. So this cannot be 9 there, because again, this adds up to 15. This has to be 4 through 9 also. This is 4, 5. Again, this adds up to 15. Remaining digits in column 1 are 0, 1 through 5. Okay. Can this ever be 4 and 5 here? Oh, this can't be 4, 5, or 9. We have a 6, 7, 8 triplet in column 5, which eliminates 6, 7, 8 in the rest of the column. Well, there you go. So this is 4, 5, and 9. Can this ever be 4 and 5 here? That adds up to 9 by itself. 9 plus... yeah, it could be. Can this ever be 9? I guess so. Yeah. So this has to be at least 4, 9 plus 10, 19. So this adds up to 19 at least, so it cannot be 4 here. Well, where's the 4 in column 6? It has to be here. So this is 4, which makes this 5, which makes that 4, which means this can't be 4 here. Again, this could be 19. We need a 5 here. So then it has to be 19. Because if it's not 19, 5 plus 9 plus 2 and 3 adds up to at most 19. That's the reason why. There's no other place for 19 in column 6, so this has to be a 5-9 pair, and this must be 2 and 3, which means this can't be 2 and 3 in the rest of the column here. This can't be, this is 6. So this cannot be 6 or 9 to add up to 17. The oranges then are 7 and 8, which means this cell is less than that cell, so this has to be 6 or 7, which means we are guaranteed an 8 here, which means this has to be guaranteed a 7 here. This is 7, 8 as a pair, so this cannot be 7, 8. It's 6 and 9. So no 7, 8 here. This is 6 and 9. So this is 7 or 8. This 6 eliminates 6 here, so this is 5, which eliminates 5 in the rest of the column. This is 0 and 1, so this adds up to 1. So we don't need the oranges anymore in the greens. This can't be 7 here. This is 8 or 9. Can you have 4 and can you have no 9 here is the question. I think the answer to that is no, right? If you have 4 and 5 at maximum, plus 0 and 1, plus 2 and 3. Oh, wait, no, that adds up to 15. That's fine. Can you have 5, 9? No. So this has to have, it's either 4, 5 or it's 4, 9 here. If you have 4, 9, it's 0, 1, 0, 1 here. If it's 4, 5, this has to be 2, 3 with 0, 1 here. So 4 is guaranteed to be here, which means this can't be 4. So this is 5 or 9 here. Let's see. So either this is 2, 3. Oh, that's interesting. So how does this add up? If this is 4, 5, this is 2, 3, and this is 9, 0, 1, which is 10. If this is 4, 9, this is 0, 1, and this is 5, 2, 3, which is 10. So this is always 10, so this adds up to 16, or it adds up to 17. I don't think this can ever be 4, 5, right? Yes, it's 16 or 17. If you have 4, 5, 4, 5, this is at minimum 4, 5, 4, 5, which adds up to 9 times 2, which is 18, which is too large. So this cannot be 4 or 5 here. Can you have a 9 here? Oh, we have a 5, 6, 9 triplet, actually, in row. Which row is this? 1, 2, 3, 4, 5, 6, 7, 8. Row 8. Which eliminates 5, 6, and 9 in the rest of the row. So this cannot be 6, 9. This becomes a 7, 8 pair, which eliminates 7, 8 in the rest of the column. This can't be 5, 6, 9. This can't be 9. This is a 7, 8 pair in row 8, which eliminates 7, 8 in the rest of the row. So that means this can't be 7 or 8. It's 4, which eliminates 4 in the rest of the column. That's interesting. Oh, we have a 4, 5, 6, 7, 9 sextuplet, but that doesn't help us any, right? Again, this adds up to 15 here. Oh, yellow adds up to 19, right? 2, 3, so 4, 5, 4 plus 6. So that's 19. 2, 3, which is 5, plus 5, 9, which is 19. So this must add up to 19. If this is 9... Okay, so this is at minimum 4, 5, and 8, which is 17. So then this must be 0 or 1. And you have 1 degree of freedom here, so this cannot be 6 or 9. This can't be 7, 8, or 9. So again, you could have 6, 4, and 8 here. Or, yeah. So we have a 0, 1, 0, 1 pair in row 10, which eliminates 0 and 1 in the rest of the row. This must be 2 and 3. Since this is 2 and 3, this cannot be 0, 1, 0, 1, and 4, 9. So this has to be 2, 3 with 4, 5. So that makes this 9. This 6, this is 9. 6 eliminates 6 here, so it's 5. This is less than 5, so it's 4. This can't be 4, 5. It's 6. This can't be 5 or 6. It's 4, which eliminates 4 here, so that's 5. That eliminates 5 in the row and the column. This can't be 9 because of 9 in the row. So this must be a 2, 3 pair here to add. This 4 eliminates 4 here. So this is 5 and this is 4, which eliminates 4 here. That's 5. That's the 1 degree of freedom we lost. Wait, that's 5, 5, and 8. That doesn't work. Huh. Interesting. That's not good. Ooh, bad. Okay, where did I mess up? Let's just restart then. Keep the time. 3 digits. 0, 1, 2, 3 is 6 times 4 is 24. 7, 8, 9 is the max you can have. So this is 7, 8, 9. 0, 1, 2, 3. Therefore, this is 0, 1, 2, and 3. This must be... So the white digits, this cannot be 0, 1, 2, 3, or 7, 8, 9. So it's 4, 5, 6. We have a 4, 5, 6 triplet. And this must be 0. That's still the same. These are... I guess we still have to do that then. 0, 1, 2, 3. So this is minus 3, minus 2, minus 1, minus 0. In rows 3 through 9, we just have 4 through 9 remaining. But again, to add up to 15, which this is, this must be 6 through 9, 6 through 9, 6 through 9, 6 through 9. Again, these two must be different than these. So these are both orange, which makes this green, adding up to 15, which makes this the orange adding up to 15. This can't be orange because it eliminates there. So these are both green. These are 6 through 9 also. This has to be 3 digits adding up to 15 and minimum 4, 5, and 6. So it's 4, 5, and 6, which eliminates 6 here. This can't be 9. This has to be 7, 8, 9 here. Oh, it's 19. That's where I messed up. Okay, so that's the problem. Okay, well, Anyways, this can't be... We're missing 6, 7... This is 6, 7, 8, 9. So this is to be 4, 5 pair. This can't be 4... this can't be 0 through 3. But we have 4 through 9. This is 0, 1, 2, 3. Okay, yeah. So the problem was I thought, for some reason, I thought this was 18. It's actually 19. That was the issue. So everything is still fine. Then this is still the same. 5, 9. This is 2, 3. 0, 1. This is then... This has to be 4, 5. This is 9. We have... This can't be 0, so it's 1, 0. This is 2 and 3. Actually, that's not true. Let's continue on. Because I think because I messed that up, this is not... Yeah. Okay, so this is definitely still 2, 3, 5, 9. This can't be 5 or 9. We need a 4. This cannot be 9 here. So this has to be 4, 5 going up to there. So this is 6, which makes this 4. This is 7, 8. Yep. 6, 7, 8 as a pair, which eliminates 7, 8 here. No 7, 8 here. No 6, 9 here. This 4 eliminates 4 here. This is 5, which makes this 4. It can't be 4 or 6. It's 5. No 5 here. This is 0, 1, 2, 3. This has to be 6, 4, 5. And this cannot be... This digit is 4, 5, or 6. So this must be less than that. So it's 4, 5, 5, 6, 6, 7 at least, and 7, 8. So we have a 6, 7, 8 triplet again. 8 eliminates 8 here. This is definitely 4 here. So it's 4, 5, or 9. This is 5 or 9. We again have the 5, 6, 9 triplet in row 8. So this can't be 9. This can't be 5, 6, or 9. So it's 7, 8 as a pair, adding up to 15. We can remove the oranges and the greens. 8 is guaranteed here, so 7 has to be guaranteed here, so this cannot be 7. This is at least 4, 5. So we have 4, 5, 6, or 9. This is, again, not 0 through 3, 4 through 9. This is 0 through 5, and this must be greater than 3. So this is 4, 5 here. 5, 6, 9 eliminates 5, 6, and 9 in the rest of the row 8. We have a 7, 8 pair, so this can't be 7 or 8. It's 4, which eliminates 4 in the columns and rows. Again, this is at minimum 17. This adds up to 19. That's the reason why we messed up. So 17 plus 2 at most adds up to 19. So we have 2 degrees of freedom here, right? If this is 5, 4, 8, that's 17. We have 0 can go up to. Or if this is 0, 4, 8, 5 can go up to 7. If this is 0, 5, 8, 4 could go up to 6. So this can't be 9. Okay. This can't be 0. So if this is 0, 1, this is either 2, 3 here, or it's 0, 1. If it's 0, 1, obviously this can't be 1, so this would be 0, that would be 1. Yeah, so not necessarily here. So again, this is 10, and so it adds up to 16 or 17. We're not sure which. It cannot be 4, 5, and 4, 5, so this can't be 5 here. This adds up to 15. Can you ever have 0 here? No. 0, 5, and 9 adds up to 14 at most. Can you have 5 here? 5, 4, and 6. The problem is if this is 5, so this can't be 4. If this is 4, 5, that forces 4, 5 to be here. But then that would make this a 6, so this would be 7 at least. So 4, 5, and 7 adds up to 16 at minimum, which doesn't work. So this cannot be 4 or 5 here. It's 1, 2, or 3. This can't be 5, because that would require that to be 4. 4, 5, and 3 at minimum adds up, at maximum adds up to 12. So this can't be 5. Okay. If this is 5, we have 5, 4. So if this is 5, this is 4, this is 6, this would be 7, so this would add up to 17. So then you'd have 4, 5, 4, and 3 at maximum. So that'd be 9 plus 7, which is 16, which is too small. So this cannot be 5. Um, um, hmm. What else do we have? Hmm. Oh, the outlined squares are different digits. We have a 6, 7. We have a 7, 8, 9 triplet in the outlined squares. So that eliminates 7, 8, 9 in the rest of the squares. This can't be 7, 8, or 9. It's 6. So this must be 6 and 9, which eliminates 6 here. So it's 7, which forces this to be 8 and 7. 8 eliminates 8 here, so it's 7 and 8. This can't be 6 or 7. It's 8, which makes this 7. 9 eliminates 9 here, so this is 8, which eliminates 8 here. This 7 eliminates 7 here, so this is 8, which eliminates 8 here, so it's 7, which eliminates 8, 7 here, so that's 8. Okay. So this adds up to 17. This can't be 7 or 8. We have, well, that's not helpful. A 4, 5, 6, 9 quadruplet. This adds up to 17, so blue adds up to 17. You could have 0, 4, 4, and 9, which is fine. This is 8. So again, these 3 must add up to 11. Okay. We have the outlines. The 6 cannot be in the outlines anymore, so this is 4, which eliminates 4 here, so it's 6. 6 eliminates 6 here, so it's 9 and 6. We have 6 and 7 in the outlines. Can't be 7, so this is 8, which makes this 7. That 8 eliminates 8 in the outlines, so this is 9. We only have 3 other digits in the outline, so that's not helpful, right? We have 1, 2, whoops. 1, 2, apologies for that. 3, 1, 2, 3, 4, 5, 6, 7. 8, 9. Outlines. Not so helpful. Okay. This can't be 9, so this is 7. 4, 5, 6, 9. This can't be 7 here. This adds up to 15 again. Could be 1, 5, 9. There's a lot of possibilities. This can't be 9 here. So this cannot be 4 and 5, because that would eliminate all possibilities for this cell here. So this cannot be 2. If you have 2, that requires this to be 4 and 5 to add up to 19. 2, 8, 4, 5 would add up to 19, but that would eliminate all possibilities here. So this cannot be 2. Therefore, we do have a 0, 1 pair in row 10, which eliminates 0 and 1 in the rest of the row. This is 2, 3. To add up to 15 in this region here, it would have to be 0, 1, 0, 1, 4, 4, 9. But since this can't be 0, 1, it's 2 or 3, this must be 4, 5, 4, 5, and 2, 3. Which eliminates 2 and 3 in the rest of column 6. This can't be 2 or 3. This is 1, 0. This is 1. This is 9, which eliminates 9 here, so it's 6 and 9. 6 eliminates 6 here, so it's 5. This 5 is greater than 4, so this can't be 4 or 5. This is 6. This can't be 5 or 6. It's 4. 9 eliminates 9 here, so it's 6. 4 eliminates 4 here, so it's 5. This is 4, 5, 6. And this must add up to 12. Or sorry, 17. So this must be 2 here. So no 2 here, no 6 here. 4 eliminates 4 here, so this is 5 and 4. We have 2, 3 in the outline square, so this can't be 2 or 3. It's 1, which makes this 3, which makes that 2. That makes that 0 and 3. 0 eliminates 0 here, so it's 1 and 2. 2 eliminates 2 here, so it's 3 and 1. 3 eliminates 3 here, so it's 0 and 2, which makes this not 1. So that's 0. This can't be 4 anymore. This is at minimum 5, 6, and 8 then. And 5, 6, and 8... 9 eliminates 9 here, so this is not 9, that's 5, that's 9. 5, 6, and 8 is at minimum 19, so therefore it must be 5, 6 here, this is 0, which eliminates 0 here, this is 1, that's 0. So it's 5, 6, and 5, 6 is a pair, 6 eliminates 6 here, so this is 5, that's 6. This adds up to 15. So these 2 must add up to 11, because it's 15 minus 4 is 11. And you cannot have a 1 adding up with another digit to add up to 11. So this is 3 and 8. 3 eliminates 3 here, so it's 2 and 3, which eliminates 3 in the square, so this is 2, and this is 3. Yeah, aside from just misremembering what the yellows sum up to, this is pretty straightforward. Very similar to the doppelganger. Well, not similar to. Yeah, I mean, kind of. It has a 0 through 9 with certain digits missing. But that's pretty much it. I don't know. Pretty cool. Pretty nice little puzzle. I like the colors. And I think this is referencing a painting and a... What is it called? It's a cubist painting, right? So similar to Picasso when he was I think he did a cubist. He had a cubist period here. Abstract, I guess. I think this is more cubist than abstract. I think it's also abstract, I think, but I don't know. It's been a long time since I've studied art, and I don't remember very much of it. So I shouldn't be talking about it because I'm not anywhere close to, like, even experienced with it, so. But, nice little puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.